Welcome viewers. Today we are going to discuss the basic knowledge of parallel in, serial out shift register. A chip of shift register is used to convert a string of data from parallel to serial to perform this operation. A shift register is required the data to be entered in a parallel manner and output in a serial form that is described a parallel in, serial out shift register. We use this shift register because in shift register, the data is applied in a parallel fashion to the parallel input from D0 to D3 of the register. We get the output serially, one bit at a time from D0. This shift register would require 1 clock pulse to load and 4 clock pulse to be unloaded. As an analogy, let us consider a vessel. We pour water into the vessel from numerous faucets in the parallel fashion, which we can see in the figure, which fills the vessel. Now, let us analyze that there is a tap at the bottom of the vessel by which the water is passing out serially. In parallel in, serial out shift registers, the data is also applied in a parallel way and read out the output serially as shown in the figure. This figure shows the circuit of a parallel in, serial out shift register, where we use the combinational circuit which consists of logic gates and one control signal which controls the operation of parallel input and serial output. Then the output of NOT gate is connected as one of the input to A1, A2, A3 and the other input of A1, A2, A3 are B, C, D. A is directly connected to the D0. The direct control signal is connected to A4, A5 and A6. If we observe, then we can see the output of the first flip-flop is connected to A4. The output of the second flip-flop is connected to A5. The output of the third flip-flop is connected to A6. The output of all the OR gate is applied to the input of these flip-flops as shown in the figure. A single clock pulse is applied to all the flip-flops. Now let us discuss how the data to be loaded. Here we use the data 1101. Now we are going to apply the control signal become 0. The output of the NOT gate becomes 1, which is load mode or active low. Then all the inputs are loaded to the output of these AND gates A1, A2 and A3 because they are enabled, and at the same time all the OR gate also enables as shown in the figure. Then that value is going to be loaded here. So when the control signal becomes 0, the data to be loaded to the inputs of each flip-flop. Now we are going to apply the control signal become 1. The output of the NOT gate becomes 0, which is shift mode or active high. That time A4, A5, A6 are enabled. When we apply the clock pulse, the data to be shifted in this way. This figure illustrates the truth table of parallel in, serial out shift register. While the control signal has become 0, then the data to be loaded. The data is 1101. While the control signal has become 1, after applying the first clock pulse, the data to be shifted as like that. Q1 becomes 1, Q2 becomes 1, Q3 becomes 0 and Q4 becomes 1. When we apply the second clock pulse, the data to be shifted in this manner and so on. Timing diagram. During the first clock pulse, Q1 becomes 1, Q2 becomes 1, Q3 becomes 0 and Q4 becomes 1. We apply the second clock pulse, Q1 becomes 0, Q2 becomes 1, Q3 becomes 1 and Q4 becomes 0. When we apply the third clock pulse, Q1 becomes 0, Q2 becomes 0, Q3 becomes 1 and Q4 becomes 1. Finally, when we apply a fourth clock pulse, Q1 becomes 0, Q2 becomes 0, Q3 becomes 0 and Q4 becomes 1. In this way, we can implement the timing diagram of parallel in serial out shift register by shifting process. In today's lecture, we have learned the basic concept of parallel in serial out shift register, the circuit operation of parallel in serial out shift register, the timing diagram of parallel in serial out shift register. With that, we are at the end of this lecture. In the next lecture, we will meet again. Till then, practice the relations repeatedly. Thank you and goodbye.